for joining. So what I'm going to talk about, it's a tale of two clouds, analytics platforms at ING. And for those of you who read the book A Tale of Two Cities by Charles Dickens, it starts with a very famous sentence. It starts with, "It was the worst of times, it was the best of times." And that's exactly what I want to take you through in this talk, because I'll talk about 5 years of experience of running analytics platforms at ING, hopefully so that you don't make the same mistakes that we did over the last 5 years. Take some lessons away that hopefully you find entertaining and interesting. And who knows, you might even be able to apply when you go back to your job, or even better, if you join my department. First of all, ING, I don't know how many of you are Dutch. How many of you are Dutch? Okay, that's great. I know for sure you know what ING is. Who's not Dutch? That must be the rest. Good. So we're still at 100%. Everybody knows what ING is? Yeah? All right. Well, okay. Well, corporate slide, so I still have to go over it. But first thing, ING at a glance. So what is it? Uh-oh. So it's 60,000 employees all over the world. That's a lot. That's a football stadium full. Unless you're Barcelona, then it's about 6/10. 37 million customers all over the globe. That's mostly the UME customers, as we would call them, the retail customers, right? Those are the big numbers. But that's not the only part that it serves. It's also for big corporates like Ahold, Heineken, those kind of things, Akzo Nobel. And of course also SMEs, or MKB as we call them in the Netherlands. But that's about ING itself, and analytics platforms are inward focused, right? So it's for the internal people in the company. That's who we built this for. It's not like we send you as a customer an analytics platform to look at your own transactions. Might be an idea, but we're not there yet. So what does that mean from an analytics platform? So currently it's about 2,500 people who make use of these platforms, hundreds of projects. And the good thing to realize there is an analytics platform is more than just a place where you have an IPython notebook and a data scientist goes loose with their GPUs and does LLMs and those kind of things. It can also be as simple as somebody in the front office wanting to know, hey, so somebody who sells, somebody who sells loans to large corporates, for example, that just wants to get a dashboard on how has the evolvement of loans gone over the last few years. So that should immediately paint you a picture that these 60,000 people, well, they're not all of them on there yet. We'd like to, right? We want to become more data-driven. Whether that should then be all of them, well, let's leave that in the middle. But let's say it should grow even further. But the first problem we face, of course, is how do you build something for everyone? Right? Sadly, we don't do search where you just get a search bar and that's about it. It has to be more than that. But how do you deal with somebody who tops off at writing a SQL query versus somebody who wants to train LLMs, GPU enabled, and so on and so on and so on? I wish I had that answer for you. Talk to me in another 5 years how you do that completely successfully, but we learned some things on the way. So where we stand now, right? First thing that I want to focus on is that analytics platforms are a product, just like anything else, right? If you get your phone out, don't do it now, wait about 50 minutes, but if you get your phone out and you download an app, you expect a good experience, because if you don't get it, you delete the app and go somewhere else, right? If you buy a car, you expect it to go from A to B without too much hassle, right? If it doesn't do that, you get rid of it and you go somewhere else. And my approach would be, why would it be any different for an internal company use tool, right? Because it's still your experience. So what does that mean if a product is good? And what does that mean to most people? Or at least if you're building the product, what should that mean to you? That you basically need to answer 3 questions at all times, right? Is it desirable? Does somebody want to, does it solve a problem for somebody, right? Is it solving a problem? The second one, is it viable? Will somebody pay for it, right? Because it can be all desirable, but like an app, most apps, if they're not free, you don't download them. Some apps you are willing to pay for, but where's the boundary between what you're willing to pay for what you're going to get out of the product? And then the last one, of course, is it feasible? Can we even buy it? And that one, of course, is very much tied to, does someone want to pay for it? There, I think most of us here are engineers, former engineer. Now I sit in meetings, but yeah, we can build almost anything if you give us enough money and time. right? We can do almost anything. But not everybody is willing to give us that much time and that much money to just build anything. There is a sort of balance to be found. And again, why would that be any different for an analytics platform? Of course, it's a little different if you're doing this for an internal employees versus, but the same thing applies, right? It's a bank. They want to make money. So in the end, if it's not worth the investment, they're also going to do away with it. But then back to analytics platforms. We have a lot of data as a bank, and it keeps growing. We get more insights in the kind of things we use, and not just the behavior of our clients, whether they're large corporates or you and me, but also the insights that we get out of how are our products being used? Like how many people are on the analytics platform? Where do they sit? Where do they come from? A lot of data that kept growing and growing and growing. But if I take you back 5 years, it was a struggle to look at all that data, right? We came from the point where it was in an Excel sheet. And at least when I studied, the maximum amount of rows that you get into an Excel sheet was about 64K, I believe, something along those lines. If you had more data than that, it was beyond my ability at least to do anything about it. Then I learned how to code. It got a little bit better, but let's say we topped out at 64K. Then when I started at ING about 10 years ago, the first thing that was really coming up was Hadoop. Right? It was the big data was the big thing. Data as oil, well, all the T-shirts that you'll probably found at the conferences that you attended 10 years ago. And Hadoop was great, but it also had limitations, right? You mostly had to run an on-premise cluster of actual servers. It had the famous small file problem, right? Too many small files, and at some point, the master node just says, it doesn't work anymore. So we got bigger, but it was still impossible to do anything that we wanted. Again, probably back then, if you spend enough time and enough money, you could get there. But from a bank's perspective, there's only so many things that we want to do. Fast forward a little bit, right? So what did we see? Well, we knew at about 5 years ago that this Hadoop thing was not really going to scale even bigger, unless we, of course, buy a lot of new hardware and so on. So about 5 years ago, my department also said, okay, let's look at public cloud. Right? Let's see if we can do something there, because at least we get out of the data center business, right? Or at least out about the many server business. But, and I'll get to you in a second as to why, that wasn't exactly as straightforward as we'd hoped to go to public cloud as a bank, right? Why? Mostly because of us, including me. My money sits with ING, some of it. Most of it's in my house, I'm still paying for it, but a lot of money, little money sits with ING. And it's a discomforting feeling like, oh, then where does it go? Especially 5 years ago. I think maybe you guys knew better than most 5 years ago what actually happened with public cloud, but to the general public, that was a scary thing. And perception is everything, right? Because a bank runs on trust. You trust your money to be safe there, or your mortgage, or your whatever, and so on. But still, we wanted to grow bigger. So what did we do? We said, we wanted to make this big and bigger. And we want to go to public cloud. But we probably can't get there in one go. So okay, then we go cloud native technologies first. So Kubernetes, basically. 5 years ago. So it's not as omnipresent as it was now. It was a bit of a guess. Right? Mesos was also a big thing then. Well, for those of you who remember. But yeah, we said go cloud native first, because that will at least smoothen the path to public cloud. And we're a bank, right? We want to get value out of it. So at all times, we needed to answer the question, is this still feasible, viable, and desirable, right? The continuous question, because it remains a product and you need to prove yourself over and over and over again. A little bit of the context in which a bank lives. And actually all of us live when we're writing software, but some of it is specific to banks, some of it is relevant to all of us. So I'm going to play a little bit of a game. I call it, let's see if you recognize these terms, and I'll ask actually one of you, or all of you, if you know what they mean. This one. Who doesn't know what this means? It's a GDPR, yeah? It's privacy law in the EU, which actually from a bank's perspective helped. You like, why would that help? It makes it more stringent. Yes, but one, it makes things very clear. It's actually one of the more clear legislative pieces I've ever read. used to be my job, right? It very clearly states what you are, when you are supposed to ask for consent, when you don't, and what you can and cannot do with privacy-sensitive information. So it helped, because it also made it the same everywhere in the EU. Right? And that's not true. If you go back to the 40 countries where ING operates, this is not the same in every country. Still, to this day, and it will probably never be, because different countries, different rules. Okay, so this one we know. Who doesn't know this one? All right, awesome. So, this one is actually the one that made public cloud 5 years ago really difficult. Whether this ruling was exactly 5 years ago, I'll leave in the middle. I think it wasn't exactly, but it was coming. Schrems is actually a person. It's Max Schrems. And there was two times that he actually said to the data protection authorities of the EU, like, hey, if you send data to the US, I'm not sure it's really safe there. Because I think that there are really no such data protection rules in the US. Like if the NSA says that I want to look at that data, and they do it under a gag order, so you cannot be, they will not allow Google or Amazon or Azure or Microsoft to let you know that they're looking at your data. There's nothing you can do about it, right? You don't know. And if you're working on one of these public clouds, regardless of whether their servers are in the EU, it's an American-based company, so that applies. So this one made it difficult because it basically meant there was no unilateral agreement between the US and the EU around privacy sensitive information and what you need to do to protect it. Right? Done with lecture on that one, so now you know. Made it more difficult. By the way, still not solved. Right? There is still no unilateral agreement between the EU and the US that states what the exact rules are there. This one. Anyone? It's closely related to the previous one. US Nexus was the ruling. Some of you might know it as the Patriot Act. Does that say more? Yeah. This came about, I think, but correct me if I'm wrong, right around 9/11. Right? They were scared shitless for good reasons. And they said, oh yeah, we need to be able to see everything. Our security services should get access to all the data that they need to make sure there's no terrorist act that they can manage. And this one, I kind of mixed it together with the Schrems II ruling. Those two together make sure that if you're on a US-based company, that they can pretty much touch your data, regardless, again, whether it sits in the EU, on physical servers. As long as it's an American company, this is relevant. Pikachu, the Pikachu Act? No, this was this was the famous big data versus Pokemon. I played it again 2 weeks ago. I've been in this field for 10 years. I still fail epically. And actually, I play a lot of Pokemon, so I would say at least both of us should know, but I still fail. No, this is not a one. This is actually one, Dora. No, and I don't mean the adorable Mexican American girl that goes into the jungle. I mean a different one. Anyone know this one? This one is, yeah, all right, awesome. You work in the financial sector then? Now, so the DORA metrics are something else, indeed. Yeah, so it's also not the DORA metrics. No, the DORA is the digital, I wrote it down, the Digital Operational Resilience Act. And what that means is this one is pretty new, but that means that anything in the financial sector that is of enough size, but I guess it would even apply to anyone in the financial sector, needs to make sure they don't have a giant concentration risk. Which basically means as much as if you put all your eggs in one basket, say Azure, GCP, Amazon, not good enough, right? Because what happens if it goes down? And we all say, they never go down. They never go down. Until there was a flood in Paris, about 2 weeks ago. Anyone on GCP that was in that zone? No? So entire region, sorry, not zone, region. Entire region went down because there was a flood in Paris. So it's not exactly, make-believe. And again, we've seen the financial crisis, what happens if big banks go down and so on. Too big to fail, la-di-la-di-la. Different, we can have all sorts of opinions on it, but also now in law, you need to be mindful of that you don't put too much concentration risk in one thing. This one is not 5 years ago, this one is recently. But the bank has your money, right? That's where we get, I'm not here saying that all of these things are bad or that they make it very difficult for my life as an engineer. I mean, they do sometimes, but they're there for a good reason, right? You want your bank to be safe and to be trusted, and that you can rest assured that nothing weird with your data is going on, unless you've given consent. So the talk was a tale of two clouds. So you're probably wondering, oh, which two clouds is ING then on, or more specifically, its analytics platforms? So yeah, it's a private cloud and a public cloud. So just, we call it ING private cloud. So it's a cloud for us, but it's not available to the rest. So we still do something on premise. Remember I said, you don't want to be in the big data center business anymore, or sorry, in the data center business with giant clusters, because it's a lot of hassle. Well, we still are, right? So on premise, we have something running that is actually, I think, still cool to work on. I might be, it's just the inner nerd in me, lots of servers, lots of CPUs, and so on. So just some stats. It's 44 servers, 35 compute nodes, 20 GPU cards, 8 master nodes that need to keep all of things together. But this is where it's fun, right? This is a lot of cores, there's a lot of memory for people to do analytics on. It's at least more than it sits in my MacBook, for sure. But to also contrast a little bit, what would that then look like on public cloud? Yeah, that's what it looks like, right? You click, and that's more or less what you need to go. Just going back a little bit to the on-premise part, also, you deal with different kind of problems, right? Because in public cloud, if somebody needs to do something new, they'll probably spin up their own cluster, and when they're done, they throw it away. Yeah, those 44 servers, you don't throw them away when you're done, right? They're there, you're paying for them, and so on. So how do you get the best out of those 44 servers? Well, we came up with a very simple solution, which is hilarious to explain for the last, 5, 6 years. Is everyone familiar with the concept of fair scheduling? Yeah, I see a few nods, a few no's. So fair scheduling is the idea that, let's say you, for some reason, are working on Sunday night, and you are the only one making use of this platform. All of this is yours. Go nuts, right? Mostly if we're talking about Spark and those kind of things, go nuts. It's all yours. Nobody else is there anyway. However, it's, what's the busiest day? Probably Tuesday. Everybody's working on Tuesday. It's 10 o'clock in the morning. Everybody wants to get their query in. There's 1,000 concurrent users. You get 1,000 of the cluster. Right? It's fair. You get 1,000. So you probably have to wait until some preemption kicks in, but that's how we deal with things on premise. Something that's not even relevant in public cloud, unless you care about costs. We'll get to that later. But you just spin up a new cluster, right? And they get there. But indeed, Google Cloud. So none of this really matters. You just use the managed services much. But there was another reason why we wanted to go to public cloud and why we wanted to go to public cloud now. Although that's a lot of compute and a lot of memory for a Google or Amazon, it's not all that much. Maybe some of you work in companies that deal with even a lot more data that would never fit in here. Same thing actually for ING. We just ran into the constraints of how much we can do on this hardware. There were problems that they wanted to solve and that they wanted to use analytics for that just wouldn't fit. It's that simple. So that's also why we had to go to Google and say, yeah, this thing, which, one of those clusters should scale up to 10,000 cores. That's how big the problems got that we were dealing with. So it's actual big data. It's not Google, it's not Booking, but it's still a lot of data. So also just to contrast a little bit, while I'm sure that we'll stay on premise and we'll make use of these servers, there's also a valid reason to go to public cloud. Right? There are just things that I'm happy that ING now wants to do, because it means we also want to be more data-driven and even more ambitious in the kind of jobs that we run on there. But that's, do it on public cloud. We're not going to buy the amount of servers that we need to be able to run those kind of things on premise. Okay. A little bit more into the details of what does this then look like, right? And we start with the premise that it's completely different, right? Because the one had like servers and CPUs, and one was GCP, so it's completely different. But I also said 5 years ago, the inventor of the original analytics platform was like, okay, let's make a big bet. Kubernetes. Not such a big bet, but 5 years ago, more of a bet than it is nowadays. So at least it's cloud native. We know that if it's containerized, it can probably run anywhere. It should be much more straightforward to take this to a public cloud when we get there. So that's still true. That thing is completely Kubernetes based. There's no stray VMs running anything anywhere. Everything is Kubernetes based. But then on-premise, what does this look like, right? What do people log into? What do they work with? Like, because you don't, well, some of us prefer working on a terminal, but most people like a clicky pointy thingy. And actually the clicky pointy thingy, kind of typey thingy that most data scientists prefer are Jupyter notebooks, or IPython notebooks, I should say. So that's the first thing, Jupyter Lab. Give them a place to work with the tools that they're used to. I'm pretty sure this is industry standard. I mean, there's a few, Zeppelin versus Jupyter, whatever, it doesn't really matter. They're notebooks, right? Cells, Python. Nowadays you can run other stuff in there as well, but I think it's 90% Python. VS Code, right, for the real engineers. I'm not saying that data scientists aren't real engineers, but they aren't. VS Code is just a full IDE, right? So any language that you want to run on there, also make that available to them. And the one to the right is Superset. Anyone heard of it? Worked with it? Cool, we got one. So Superset is the open source BI tool. So think Power BI, think Cognos, think those kind of things, but then an open source version. So that's actually where the vast majority of people work on. Because like I said, like if you have 60,000 employees in ING, well, at best, maybe 10,000, well, let's say 20,000 know how to write a SQL query, and they don't go into Jupyter Lab or VS Code. They go into a BI tool, and it's fine, right? It's perfectly valid. And one of the things that we did, because this is Kubernetes-based, was that we said, well, we can actually give them quite a bit of freedom within the constraints of all the regulations and risk work that we need to do. So actually, when you start up this analytics platform on-premise, you get a choice in what we call data science in a box. You get to select your pip packages, your OS packages, basically anything that you want to put in there, you can put in there after it goes through some scanning to check whether you're actually not downloading anything with massive vulnerabilities in there. But still, you get your own Docker container, if you will, that we put on there, and then you get all those servers behind attached to it to do what you want. So we actually are able to give them quite a bit of freedom and choice in what they want to do. If you want to see a demo, come to the ING booth later. But then again, that's just a clicky pointy interfacey typey thingy. Then you actually need to get this into an execution engine of your choice. And we offer a few. Quick aside, ING makes a distinction between exploration, so where you're basically exploring the data, you might be building a model or logic, and we differentiate between runtime, exploitation, whatever you want to call it. So basically, you found what you want to do, the logic, and now you're going to embed it in your business process, right? It's going to run for realsies. First one, Trino, that's the adorable little rabbit. That's basically a highly performant SQL engine. No more, no less. Completely distributed, can use, make, lose a lot of it, runs on Kubernetes and so on. Spark, I think that's, at least anyone in the data space will be very familiar with this. It's a highly distributed framework written in Scala that allows you to do very deep calculations on all sorts of things. I think that's actually the most used execution engine for the engineers part of it. Let's say the analysts, the data scientists, of course, they just run SQL queries. The one to the right, Flink, right? So in ING, we also make a distinction between three different types of patterns on how you want to get your data or your model or your logic into your business process. And they're very easy to understand. The first one is, I have a file that goes in, and that file is then made into a prediction or a logic or a model, and then a file comes out, and you can pick up the file and you embed that in whatever else is your application is doing. Could be a next best action list that then gets into your front office application. Could be fraud alerts that you might need to call the next day. Could be anything. It's very straightforward. File in, file out. 90% of them use Spark and Airflow for the scheduling. Second one is stream in, stream out. For the most of us, that will mean Kafka. Of course, not the only streaming engine, but it's Kafka in, Kafka out. That's Flink, right? It's a fairly well-known one in the data space. Flink is an execution engine where you do things in stream. They actually now also promote Flink SQL. And as the word already says, SQL, it's a little bit of an easier interface to working with streams. How many of you have worked with streaming data? How many of you find that exceedingly easy? Okay, well, if you would have raised your hand, I would have really recruited you, because I don't find it really easy. Like temporal joins are well, a nasty word. But Flink SQL is the idea that you make this much easier, right? Almost like writing a SQL query that you can do temporal joins and those kind of things. And the last one is that's the Scala logo, because we also built something in-house. The last interaction pattern is API in, API out. So it's basically stateless. We take your model, because this is really focused on machine learning models. We take your model, we wrap it in a Docker container, build an API out of it, and you basically state, okay, this data needs to come in via API, and you get a prediction pushed out again. So also the model doesn't keep any of the data, it's completely stateless. Right? So three interaction patterns for these execution engines. Now, for you, those of you familiar with big data computing and so on, the absolute worst thing that you can get is network I/O. Network I/O is usually the bottleneck on how fast you make things want to go. But because we're talking about big data and a lot of data, petabytes of information, there is undoubtedly a moment that you need to go to your deep storage, if you will, S3 or those kind of things. But preferably you don't, especially if you have as much memory as I put on the previous slide. You're like, okay, if we can put it in cache, then we don't have to hit deep storage. It all becomes much faster. And that's what Alluxio is. It's a caching layer that sits between basically execution engines and the deep storage. And in ING, deep storage is called is a vendor base from Dell, ECS, S3 interface, as most of us would know. So it's basically S3. Although, as one of my engineers fondly always says, there's only one S3, and that's Amazon S3. Everything else is a knockoff. And then the last one, there is also icebergs in the ocean that I described of the data. It's the format that we use for files, so iceberg. Why is there a small dotted line? It's because my department and us, we work on the stuff above the line, and the thing below is something that we get from the infrastructure department at ING. They provide a general S3 service. So this was about contrast, right? Tale of two clouds. So now we go to the public cloud. What does that look like? All right, this one is easier. They're all managed services by Google. I took the liberty to add names behind the icons because I I also didn't know what those icons were. The first one is Vertex AI. It's a workbench, right? It's basically Jupyter Lab, VS Code, all of those things combined, but including a lot of availability for MLOps, so machine learning lifecycle kind of things. Looker is let's say the GCP managed services for BI, so dashboarding. So it's the equivalent of Superset. For execution engines, Dataflow and Dataproc, that's actually just Spark and Flink on Google. They are managed services again, so we don't build them themselves. We just say we would like that one. And what my department does is take all of those things, including BigQuery, and we harden them, which basically means we make sure that you cannot breach out to the open internet because, again, we want to protect your data. And we set certain settings and best practices on how we want to use them. And BigQuery, it's not exactly an equivalent of Alluxio, but that's the data warehouse. The on-premise equivalent will probably be the Hive Metastore, but let's not get into those details. So this is basically data warehousing where you set your tables, where most people interact with. And then underneath, Google's version of S3, Google Cloud Storage. But for those of you who are very much into this space, there might be a few of you. Is there anything that you notice between the left and the right? This is probably a trick question. Actually, everything on the left, except for Dell, ECS, is open source. It's all open source. And actually, the frameworks of which most of the majority of the stuff in Google is based on are the exact same open source frameworks. They are just the managed Google versions of that. It's Spark, it's Flink, it's I'm not sure whether Jupyter is actually embedded in Vertex AI, but it at least comes close to it. Why is that relevant? Well, of course, it makes it a little easier for us engineers if you have to deploy it, understand it. If it's the underlying same principle, that makes it easier. But remember, it's a product. And what is the worst thing to do when you upgrade your product or you get a new app? If you have to relearn the entire thing because everything changed. And for the most part, this should be equivalent. Of course, it looks different. And of course, the menus are quite different. But if you know Spark, you know Spark. You know how to do the settings. You know how to run interact with a notebook. Again, think of it from the perspective of it's a product and we have users. And you want to give those users the best experience that we can get. So actually, it's not so different. Between on-premise and public cloud, we try to keep it as much the same. Actually, it's also one of the reasons why we went with GCP versus, for example, Azure or Amazon. Because Azure and Amazon don't usually base their stuff. Well, they might base it on the same open source framework, but then put more of their own sauce of it than Google does. Whether that's right or wrong, that's not my opinion. It's just the facts. Lessons learned over those 5 years. Well, the picture, I think, says it all, right? It's definitely not a straight line. It's like, oh, this is where we are now, and in 5 years, we're exactly going to be there. The vast majority of bank would like to think it's that way, right? Give me a roadmap in 5 years, and that's exactly when you're going to end up there, and these are the milestones in between. Well, they look good on paper, but I think all of us as developers know that that's never the truth. And like I said, 5 years ago, we were like, can we go to public cloud in one go? Right? So let's skip this entire new version of an on-premise environment. But we couldn't, right? The Pikachu slide, I think, eloquently stated the point that it was difficult for us to do that in one go. So it wasn't a straight out. We went on-premise again first, but at least made choices that we thought that would be in line with where we think we will be in 5 years. Or back then it was probably 2 years, but 2 years turns into 5, and before you know it, you have gray hairs. Same thing from technology perspective, right? The things that I put on there are the ones that we still use, but there are also still frameworks and things that we put on there that aren't used anymore. The best example I can give is we actually invested quite a lot of time and effort in Amundsen, which is a data catalog. Because it might be good if you're doing analytics that you actually understand the data that you're working on. And don't get me wrong, it's not the fact that we think that that was a bad idea and no user ever used it. But what we found out was, one, the technology framework was a little less than what we hoped it to be. So we kind of made the wrong bet there, if you will. But also that it turns out when we talk to our users is that once they were on this analytics platform, they already knew which data they needed to use. Right? They got there. It's a fairly technical product. So they already knew, yeah, I don't need to look at a catalog, because actually the way that ING operates is that there's a bit of a difference between where the data comes from and the analytics platform. It's not one and the same. So it was actually much more valuable for them to know in, let's say, the real data ocean where everything sits and whether it was then already available on the platform. So we learned over those 5 years, like, okay, we were too late in the journey of this user to really add value with this data catalog. So regroup, work together with the data people, build the platform there and make sure it integrates. This is all very technology driven, which makes sense if you're at a developer conference, but I'd be remiss if I didn't say that the winding road is not just frameworks, it's also very much in how you do this. 5 years ago, these platforms were used by one department, had maybe tens of fairly highly technical people on there. And at some point it was selected as a global standard. That also means that the team grew quite a bit. It started with, I don't know, 3, 5, 6 people or something along those lines. Nowadays it's 70. And I don't know how many of you work in big teams with a product that has multiple squads or teams working on it. The point here I'm making is we also had to learn how to grow as a team, because it's completely different working with 6 people versus 70. Right? With 6 people, you probably know the names of their pets, or wives, or dogs, or those kind of things. If it's 70 people, well, you're already doing a pretty good job if you know everyone's first and last name. Probably first name. Most of the last names are not put on Slack. Right? So I cannot overstate how difficult that was to figure out how do you work collectively together. Especially in the previous slide, if you looked at all those technologies, it's really hard to put like clear boundaries between teams. Say, you're responsible for this, and then you're almost end-to-end responsible for that, and you have little to no interaction, at least from a dependency perspective. I can tell you I tried. It was completely impossible, because there was always a spaghetti line going somewhere that made this cut almost impossible to do. So that was definitely a winding road that keeps winding on. We keep changing, not too often obviously, but we keep changing on how we organize internally to actually try and build these things, because it's hard. One of the things that also helped, but then back to the technology part, is that we kept it open source. And there's two reasons for it. One is it's open source, so you get a lot of updates for free. You don't have to wait for a vendor to embed those and so on. But two, it also makes sure that you're not stuck with something from a licensing perspective, right? I think all of us will know the fallacy of, hey, the tool is not so great, but yeah, this is a 3-year contract and we're in year 1.5. What are we going to do? Yeah, we're kind of stuck with it. But yeah, from an open source perspective, you do away with it, you try something else. And the other part is it's a little bit more engaging for engineers. I think, at least for me personally, it was more engaging to work on open source software than versus a managed server, like managed services like something from IBM or and so on. They're good tools, don't get me wrong, but I find it more engaging as an engineer to work with open source frameworks, because not me, but most of the other engineers got open source commits out of it. We have commits, people that committed to Spark, to Airflow, to Jupyter, all that. More than just an update to the README file, by the way, actual, real pull requests to open source kind of things. It keeps them engaged, right? It keeps them interested. Especially, don't forget, we live in a very regulated environment. So not all of your work is going to be working on the latest and greatest open source frameworks. You'll also have to do risk paperwork. That's how it's going to be. Did I forget anything? I probably did. Doesn't matter. Lessons learned again over the last 5 years. It was writing well, but I also want to contrast them a little bit. So what is or was the obstacle, and how did we tackle them? First of all, hard to find skills. You're all here. You'll probably get your LinkedIn inboxes filled with opportunities from all sorts of companies all over the globe, and for good reasons, because you can do things that not a lot of people can do. Same thing that people in data or engineering or the intersection of those, they are not very hard. They are very hard to find, and they're also very easy to leave if they're not engaged. Because like, yeah, why would I work here if I can work somewhere else that sounds more interesting? There's always greener fields somewhere. So what we do, challenge them, right? Make the problems as hard as you can be. Again, we're not doing here deep research into the greatest, latest JVM optimization. But still, we're working on a lot of data, we're working with a lot of different people. Keep them challenged, keep them engaged. And actually, maybe even the most important thing, if you only take one thing away and you're ever in the position that I now am in, of actually having to hire people, is that your hiring process is probably the most important thing you do. I shit you not. It really is. Why? Because that determines who you're working with. That determines how fast you're going to go. That determines whether you have a good time at work. That's also why our hiring process is peer-based. You hire your colleagues. And if our hiring process is, and I'm involved, and I'm the manager of the department, and I think, yeah, we should hire this guy, but the engineer says no, it's a no. Everybody needs to say yes, because you're the one working with them. It's your own investment. If you don't think the lady or the guy is good, don't hire him, right? Keep them engaged, keep them fun, right? And especially the fun part. It's not all about coding. It should also be just fun people that you want to work with. Operating in a heavily regulated environment, right? The Pikachu slide, it's heavily regulated. That also means that it's not as easy as just, oh, go to public cloud, click this thing, try it out. It doesn't seem any good. Let's put some real data in there and off you go. It's not going to happen, especially the real data part. You might click it together and try something out, but the real data part is not going to happen. Because again, it's your data, not ours. But what does that also mean? That you need to think things through, right? Because if you know you're going to go into an investment that, oh, I'm going to try this new open source framework, but I need to do all the appropriate risk work, paperwork to actually productionize this, well, you better think twice on which one you're going to select. Funnily enough, to me, that means that you should be even better at experimenting. You should be more experimenting. Fail fast, really fast, right? Try everything. It's fine. Spin it up. I don't care. Just don't put real data in there. But try it fast. Again, continuously answer the question, is it solving somebody's problem? Am I actually solving a problem? Will somebody pay for it? In our terms, will I or another manager sign off on the fact that we, in this case, if it's open source, invest in it? so that you get to implement it. And of course, yeah, sorry, which one did I say? I said it's desirable, it's viable, feasible. Can we actually use it, right? Can we integrate it with the rest of the bank? So actually, if you're in a heavily regulated environment, you should probably experiment more because the cost of failure is high the longer you go. You can't do it by yourself. That's what we also learned, right? You saw the dotted line a few where we said, oh yeah, infrastructure department of ING, they offer S3 as a service. Please do it for us. I don't know how many you've ever tried to work on S3 at big scale, at the petabyte scale. It is hard. It is really hard. If I don't have to do it and somebody else is really good at it, please do it. Please do it for me so I can just get a managed service. Because you don't have to do it yourself. If there is another department in your company, or if it's a smaller company, another person that can help you, then just ask. Right? Same with public cloud. Why would we want to do everything ourselves? We can partner with Google. Right? We're not in direct competition with Google on these kind of things. We're definitely not in the data center business. So if they can do this for us, let us help. Work together. Right? You can't do it all by yourself, so why would you? Going back, right? It's a product. And that's where the focus will also be in the coming years. How can we make this better for our users? What does that then mean? Right? Especially if you're talking about analytics platforms and the products and embedding them in a certain process, it's kind of hard, right? You need to first make the model, you need to get the data there, and then you need to find out, how do I productionize this? How do I get this back embedded in the flow of wherever it needs to end up? Might be the front-end mobile app or something. That's a lot of systems with a lot of different teams. But if you're, let's say, you want to get a new mortgage proposition out here in the Netherlands, and you're the mortgage department, do you really care about all those things? Should you care? Probably not, right? You just want to say, this is the proposition, it needs to land in that app, and I want to take it as little time as possible. Their engineers should probably just think, okay, build the model there, the data's already there, then I just push that button and it's deployed there, then it gets this output and I pick it up and that's it. The next 5 years, I'm sure, will be about integration. Integration, integration, pre-integration, if you will. Make sure that the journey for the user becomes smooth. And then, of course, also, how do you bridge that between on-premise and cloud? And that's still an open question. I don't know the answer yet. Is there a moment where you want to say, okay, I've built something on-premise, now I want to productionize it in public cloud? Or the other way around. I've built a model, I needed a lot of compute, but to actually run it, it's fine if it runs on-premise. Right? Those are the kind of journeys that we need to look at and that we need to get better at. And of course, get a lot of people on the public cloud version of us, because I do think that's where our future lies. Our future definitely lies in the direction of public cloud. Like was already explained, the entire regulations are more clear to us. It's more clear what we can do, what we cannot do, and also how to navigate this. So there is more room to go to public cloud, and then finding a balance between what that means and what remains on-premise. Because I'm also of the opinion that we will probably not do away with this stuff on-premise in the foreseeable future. That's it. That was my talk.